I guess if you watched this, you found part 1 of this series pretty interesting. And I'm really glad because things are about to get more fun to work with. This is the last video where I talk about boring stuff, and we're actually going to render some procedurally generated terrain in part 3. The goal of this video is to teach you how to create a simple grid. And by the way, this series has subtitles, so if you don't understand what I'm saying, you can try to activate the English US subtitles. And well, before we get into action, let's do a quick recap of the last part. Rendering means visually displaying. Rendering a number could be drawing a block which height is the number. So you can estimate what is a number value by looking at the block's height. An array is just a list of elements. In our case, those elements are numbers. And rendering an array means just rendering multiple numbers. This is the last bit of code from part 1. It is not exactly the same code, but it does the same thing. If we run this, we should see 3 blocks, which position y are 0. In order to understand what are grids, which I will refer to them as 2D arrays from now, we should fully understand every step we did until now. At first we render the number, just a block which height corresponds to that number. Then in order to render an array, we render a bunch of numbers in a straight line. The straight line array is also called 1D array, keep that in mind. Now, to render a 2D array, we should try rendering a bunch of 1D arrays. It should look something like this. Of course, we can also get a 3D array by rendering a bunch of 2D arrays, but for now I don't overcomplicate things and stick to the 2D array. If you remember when I presented the concept of rendering an array, I tried to copy and paste the code a couple times, so more blocks will be rendered. Then I tried to modify the position of each block in order to distinguish them. Of course, if the blocks have the same position, you can tell the difference by looking at them. After all of that, I simplified the code by adding a for loop instead of just copy and pasting the code fragment. I totally forgot which order I did all of these things, but that doesn't matter. We're going to do the same thing again in order to render a 2D array. First, I will skip over the copy and paste code part and write a for loop. I don't think it makes sense at all to start copy and pasting that code again, since I think you have a clear perception of our for loops and you know how they're working. Again, now in order to distinguish those 3 arrays we've rendered, we should change one of the x, y, and z components of the parts. Since we set x is equal to index 1 and y is equal to height, we're left with the z component, which I will set to index 2. Now, index 1 should move every part to the right, and index 2 moves every part in front. So far we haven't rendered a 2D array, we just rendered the same 1D array 3 times. To fix this, we should try adding a 2D array in the code, and I will let the old me explain how to do that. Alright, we can start by deleting this array. We don't need it anymore, and we can try to create our 2D array. This might look a little bit confusing, but don't worry. We just have a 2D array, which is a list of one-dimensional arrays. So a 2D array is basically 3 1D arrays, in my case. The number doesn't matter. And a 1D array is a collection of numbers. Alright? And index 1 refers to the current array, index 2 to the current number of that array. If you put here index 1 and index 2, as you see, index 1 will refer to the current array. Let's say index 1 is equal to 1 in this case. Then index 2, let's say, is equal to 3. And we refer to the third element of the first array. So again, first array
Certainly.
This is the rendered version of that array. As you see, it looks terrible, so we're going to customize it. Changing these numbers will result into a variety of heights. Take a look at what scaling looks like. Scaling means multiplying every xyz component from the position and size of a cube by a certain number. Applying colors depends on what engine you're using. In Roblox, we can set up blocks color very easy using the RGB color format. And of course, multiple cubes will make your render look better. I didn't go deeper into explaining how customization works because I think it's pretty obvious and also not related to the current topic. So that's it for this video. This one sure took me a lot of time to make and I'm really glad to finally release it. As always, if you have any questions, you can comment them and see you in the next video.